Hello dear students, in this second week we will learn of the new topics of noise, classification of noise, external noise, internal noise, noise calculation, signal to noise ratio. These are the basic terms of communication and radio engineering too. So hopefully you will understand. First of all, and also the effect of noise in radio communication. First of all, what is the noise? The definition of noise is pretty much simple. In any communication system, during the transmission of the signal or while receiving the signal, some unwanted signal gets introduced into the communication, making it unpleasant for the receiver, questioning the quality of the communication. Such a disturbance is called a noise. That means some unwanted signal. Noise is the unwanted signal that interrupts the received signal, the signal which is our desired information signal. That is called noise, which will interrupt it. Here you can see there is a transmission block, transmitter, and the receiver block. There is message transmission, and there is a channel. In the channel, the red portion is the noise. Okay, so that is the noise. And coming back to the point of the what is noise, that we'll see. Noise is an unwanted signal which interferes with the original message signal and corrupts parameters of the message signal. This alteration in communication process leads to the message getting altered. It most likely enters at channel or the receiver. Noise is an unwanted signal which interferes with the original message signal. That means it will interfere the original message signal and corrupts the parameters of the message signal. This alteration in the communication process leads to the message getting altered. It most likely enters at the channel or the receiver. It is quite a random and unpredictable. Noise signal is one kind of unpredictable signal. That is not a signal that will be deterministic. Here you can see that is an analog signal, and that's a weakened analog signal plus noise. Noise distorts the signal, noise distorts the amplitude of the signal like that. It's called attenuation. And there is a noise lower, but it's a very curly and random noise. After module this two, after making the plus, we will get this. So amplified analog signal plus noise, if we amplify it, then we can get this, but there are some distortions out of there. So noise distracts or distorts the signals like that. It mainly harms in the amplitude section. Okay. Sources of noise. The classification of noise is done depending on the type of the source, the effect it shows, or the relation it has with the receiver. There are two main ways which noise is produced: the external source, internal source. External source, natural sources, man-made noise sources. External sources of noise. This noise is produced by the external sources which may occur in the medium or channel of communication. Usually this noise cannot be completely eliminated. The best way is to avoid the noise from affecting the signal. Natural sources like the electronic storms, solar flares, radiation in space, noise generated due to thunder. Cosmic noise comes from stars. It is uniformly distributed over the entire sky. We also receive noise from the center of our galaxy and from other galaxies. Man-made noise, external source of noise. Man-made noise is like it's generated because of make and break process in a current carrying circuit. Electrical motors, welding machines, ignition systems or automobiles, fluorescent lights, switching gears. The internal source. This noise is produced by the receiver components. Internal source means that will produce by the receiver components while functioning. The components in the circuits due to due to continuous functioning may produce few types of noise. This noise is quantifiable. A proper receiver design may lower the effect of this internal noise. Examples, most common examples of this type of noise are thermal agitation noise, Johnson noise or electrical noise, short noise, transit time noise, flicker noise, resistance effect noise, and mixer generated noise. Thermal noise. It is also called Johnson noise or white noise or resistor noise. It arises due to random motion of the free charge particles. The intensity of random motion is proportional to the thermal supplied. For example, temperature. The net motion of the electrons gives rise to an electric current to flow through the resistor, causing the noise. That means that is the internal noise of a conductor. As we know, conductor carries the free charge. Some external agitation like temperature or like external voltages that will cause through. Thermal noise calculation, that is the basic thermal noise calculation. What can I say? The law or the equation. Pn is the maximum noise power, and that is the proportional to the absolute temperature. The bandwidth, delta F is the bandwidth. It can be also in some of the mathematics we can also see BW here, and that's the if we put out the proportional, we can put in a proportional constant like K is the Boltzmann constant here, and as we know, Pn is equal to Vn whole square divided by R. After calculating, we will get this. Vn is equal to root over 4k T bandwidth into R. So now the point came, the noise voltage and the noise power. There are some maths related to this type of noise. So that is the thermal noise. For example, there is an example of math. An amplifier operates operating over the frequency range from 18 to 20 megahertz. So first of all, we have to find out bandwidth. 20 minus 18 is 2 megahertz, and has a 10 kilo ohm input resistor. That means the value of R. And what is the RMS noise voltage? We have to find out Pn. The input to this amplifier, if the ambient temperature is 27 degrees Celsius. What is 27 degrees? If we find out 27 degrees Celsius, we have to find it out as a Kelvin. So first of all, the T will be 273 plus 27 degrees 27 Kelvin, and the bandwidth means BW, the delta F means the difference between these two. That means 20 minus 18, that means 2 megahertz are there, and R is 10 kilohertz. After putting this value, we will get this. The Boltzmann constant, you have to find it out. The Boltzmann constant, popularly 1.68 that is popularly known as the Boltzmann constant is just like 1.38 into 10 to the power minus 23. You will get it. After calculating this, you can get the answer. Try it at your own. Now, that is the short noise. It is produced in amplifying devices rather than in all. It is produced because of random variation of electrons or holes charge carrier. It has uniform power spectral density like thermal noise. Short noise. Partition noise. Partition noise is generated when current gets divided into two. That is the transistor. Current gets divided into two or more parts. Partition noise is higher in transistor than the diode. The device is like FET, field effect transistor, draws almost zero gate bias current, and therefore keeping the partition noise to its minimum value. So that is the noise generated by the